Welcome to Study Loop.
So in this first problem, you're told that the tank of a truck is a stainless steel cylinder as shown. So notice that the length of it, or the height of it, is 50 feet, and the radius is 4 feet. So in part A, what we want to do is find the surface area of the tank, and we're told to use 3.14 for pi. Well, we have a formula to help us find the surface area for a cylinder. The formula is A equals 2 times pi times r, the radius, times h, which is the height, plus 2 pi r squared. So now we're going to substitute in everything that we know. So we're going to have 2. For pi, they want us to use 3.14. The radius is 4, and the height is the length of this, which is 50. Then we're going to add this to 2 times pi, which again, we're using 3.14, times our radius squared, so 4 squared. So now we can go ahead and go to our calculator. So for our first term, we're going to have 2 times 3.14 times 4 times 50, which is equal to 1,256. And for the second term, we're going to have 2 times 3.14 times 4 squared, which is 16. And that will give us 100.48. Well, 1,256 plus 100.48 is equal to 1,356.48. Well, let's go ahead and look at our directions here, and they want us to round to the nearest tenth, meaning we would round one place after the decimal. So because the second one is an 8, that's going to bump the 4 up to a 5. So the surface area will be 1,356.5 feet squared. So that's the answer to part A. Now, for part B in this problem, it says the cost of the stainless steel to make the tank is $68 per square foot. We want to know the total cost to cover this tank. Well, that would mean we have to take the area and multiply it by the cost per square foot. So we would take the 1,356.5 and we multiply it by 68, and that will give us the total cost. Well, 1,356.5 times 68 is equal to $92,242. So that would be the total cost. All right, so now let's take a look at the second question. Now, in the second question, we have this party hat. So let me go ahead and draw this cone. So we have the base, which is a circle, and we have this cone here. And we're told that the circumference of the bottom is equal to 19 inches. And the other thing we're told is that the height is 9 inches. So in part A of this problem, they want us to figure out how long is the elastic. So the elastic is this band that's going across the diameter of the base. Well, we have a formula to find the radius for the circumference. Circumference is equal to 2 times pi times the radius. Well, in this case, we know that the circumference is 19 inches, but we don't know the radius. So again, we're going to substitute in 3.14 for pi. So now we'll solve for r. Well, 2 times 3.14 is equal to 6.28. So now to solve for r, we just divide both sides of our equation by 6.28. Well, so we're going to have 19 divided by 6.28. And in this case, I'll round to the nearest tenth, just like the last directions. So you would find it would be 3. Actually, I'll go 2 places. It'd be 3.03. So that's the radius. We want the diameter. Well, remember, to find the diameter, we double the radius. So we would take 3.03 and multiply it by 2. Well, 3.03 times 2 is equal to 6.06. So that would be the length of the elastic. Now, for part B of this problem, it says, how much paper do you need to make the hat? And it says no paper needs to cover the bottom of the hat. Well, in this case, what we would need to do is we need to find the surface area for this cone. Well, we have a formula to do that. The formula is A equals pi times r times the quantity of r plus the square root of h squared plus r squared. So now we know what r is from part A. So we're going to have 3.14 times r, which is 3.03. And then we're going to multiply this by 3.03 plus the square root of h squared, so 9 squared, plus our radius, which is 3.03 squared. So now this is something we can do in our calculator all at once. So we're going to have 3.14 times 3.03 in parentheses 3.03 plus the square root of 9 squared plus 3.03 squared. And then make sure you close your parenthesis at the end. So what you would find is that the area would equal to 119.18. but that includes the area of the bottom. So we would have to subtract that. Well, the space of the bottom is a circle, which the area formula is pi r squared. So that's the area of the circle. So now all we need to do is subtract this. So to find the total, we would take the whole, which is 119.18, and we're going to minus it by 3.14 times 3.03 squared. So again, we'll go to our calculator. So we'll take 119.18, and we're going to subtract it by 3.14 times 3.03 squared. And we'll find that the total surface area for the hat would be 90.35 inches squared. So that's the answer to number 2. And lastly, we have number 3. So in number 3, we're told that 1 can of frosting is going to cover 280 square inches of a cake. Now, we're given this cake here, and we're given some dimensions. Let me go ahead and draw this as quickly as I can here. So we know that the length is 13 inches. The height is equal to 3 inches. And the width of this, that's this direction right here, would be 9 inches. So we want to know, would 1 can of frosting cover the cake? Well, in order to do this, we would have to first find the surface area for this piece of cake. Well, we have a formula to find the surface area for, in this case, this is considered a rectangular prism. So to find the surface area for a rectangular prism, we're going to take, so A in this case, will equal to 2 times the length times the width, plus the length times the height, plus the height times the width. So in this particular case, we're going to have 2 times the length, so 13 times the width, which is 9, plus the length, which is 13, times the height, which is 3, plus the height, which is 3, times 9, because that's the width. So let's go ahead and simplify and see what we get. So first, we have 13 times 9, plus 13 times 3, plus 3 times 9, which is equal to 183. And then we'll have 2 times 183, which is equal to 366. So that means, 366. So let's change that 3. So that means the surface area would be 366 square inches. But remember, the 1 can only covers 280. So no, there is not going to be enough in 1 can to cover the whole cake.